To use Julia at Aviva. And I'll take you through sort of three sections broadly. I'll give you a little bit of background about Aviva, who Aviva is. I guess this is a fairly wide audience, so potentially you may not know about Aviva. And also some of the things, the background to the calculations we're doing around Solvency II and who the team are that I look after, FMS, the Financial Modelling Solutions team. I'll then take you through our initial implementation, some of the thinking that went into it and what we ended up with and where we're going to be going sort of later this year and beyond. So I hope that's interesting to you. A real life example, I'm not actually going to do a demo or anything like that, but this is a real life example of a Julia implementation that's now in production and being used by a number of our users across the Aviva group. So a bit of background first. Aviva, for those of you in the UK, you'll know who we are. We're a large UK insurance company, I think number 2 after Prudential, and we operate mainly in the UK, about half of our business, but then we're also spread across the rest of the world, in Canada, Europe, many of the markets in Europe, and across in Asia. Over 300 billion assets under management, so a fairly large organisation. And my team has been focused on building out models for Solvency II. So Solvency II, if you're in the banking world, you might have heard of Basel II. Solvency II is sort of the equivalent sort of risk sensitive capital framework in the insurance world, primarily in Europe, although there are look-alike sort of regulations springing up in other parts of the world. It had a huge, very, very long gestation period. It's been talking about it for years and years and years. It's definitely more than 7 years, but we've been actively developing our Solvency II modelling and processes for at least 7 years. And we went live finally last year, at the beginning of last year. And you can either follow a standard approach to your capital models, or you can follow an internal model approach. And to follow an internal model approach, you've got to sort of go through a number of hoops and get it approved as an internal view of your risks. And Aviva went through that process, and we were granted internal model approval in 2015. And because of the long period this was developed, we actually bought our platforms back in 2010, a product called Algorithmics. It was actually part of Fitch, coincidentally, at the time. It later got bought, and this building and this room is part of the Fitch organisation. Yeah. Anyway, so you may be aware that you sold Algorithmics back in 2011, I think it was, to IBM. And it's a banking system that's been used for many years. And we licensed it, and a number of other companies licensed it, and it's got a very prodigious user base in the insurance Solvency II world, the big multinationals, and in the UK, Prudential L&G, Allianz, the largest insurance company in the world, AXA, Zurich, Generali, to name a few. So, good pedigree, and of course, you know, we integrated it into our internal model solution, and what I'm showing here is a picture. You're not supposed to read all the details, so don't worry about that, but there's all these flows of data that come through the various businesses and are presented up into this sort of global tool, which is highlighted by this blue box in the middle, where we process that data, simulate different risk scenarios, generate capital outcomes for our balance sheet. And that calculation, then we look at the tail and look at the 1 in 200 VAR, and that generates our capital number. And all along we've been pretty much putting algo at the heart of the internal model. And in fact we created our second, so I started in 2011, a couple of years later we created our second version of it, so second generation, which was much faster than the first one, much more granular. We could run 500,000 scenarios, not 100,000. And it had a front end, a web-based front end. Of course, going back 2010-11, these things were not quite so everyday as they are now. And we actually won the best risk engine in that year. So there we are, up at the awards. So very pleased with what we did with Algo. But I guess we then toiled on for another couple of years. And by 2015, we got a little bit frustrated. So the algo system really wasn't keeping up with where we wanted to go. It was very difficult to change it. We had to go back to the vendor, IBM, make change requests, pay for changes. There'd be a long process of going to Boston, off to Amsterdam and back again, and we'd eventually get what we needed, but it was a long process and quite tortuous. So we started to think of what a better solution would look like, and we'd looked around at proprietary solutions, but still Aviva had quite a lot of peculiarities in its solution, a big organisation with some very specific aspects. So we decided to build our own solution with best of breed components. We wanted it to be very fast. We wanted this continuous self-service for the users. We wanted to integrate it with the businesses that were standard formula, so that we could do our what's called a partial internal model, and we could report the numbers out into our QRT reporting templates. And we wanted very fast run times, 5 minutes, all in the cloud, instead of on our HP data, on our data centre in Newport, Wales. So we had this sort of vision that we could do better, and we sort of knew some of the framework, but we didn't really have a calculation engine. But when we were looking, I sort of keep an eye on these things, and I came across the Julia language, and I thought in my own time I'd just prototype some of the calculations. So we took some of the core calculations, one of the loops that's the most intensive loop in the system, and it's only 200 lines of code, or well, I don't know what it is in Algo because you can't see it, but in 200 lines of Julia, we managed to build that calculation, feed in our group data, and reproduce the Algo numbers from year end 14, I guess it would have been at the time. And after a few goes, after a couple of weeks of playing around and understanding how do you benchmark these things, how do you put them in function, making all the basic beginner errors, pushing things to the outer edge of the loop, sorting out integer powers and looping those around so that they sort of inlined and compiled fast. We got the calculation, which would have taken 40 minutes in Algo, to run in 12 seconds on one desktop computer. And at that point, and every week I could see this runtime coming down. I thought, it can't be that fast, it can't be that fast. And eventually I think we got stuck at about 30 seconds. I thought, that's very quick, and suddenly it went down to 12 seconds. And just the syntax is so simple, and in fact the code looked, from when it was running slow to when it was running fast, the code hardly changed, but you just had to learn a few of the basic things not to do. And as long as you didn't do those, it ran super quick, and the code didn't need any special clever sort of syntax. So I loved the elegance of the code, the simplicity that Viral was talking about, and this fantastic speed. So from my perspective, the actuaries, the quants in my team, this should be a language that they should love, and it's giving us that speed that we couldn't get out of a proprietary solution. So of course that was just the start. We then needed to show that we could do the whole calculation, and this is a sort of a map of some of our calculations from left to right here. So some of the inputs, simulating risk distributions, generating a loss distribution on our balance sheet over 100,000, 500,000 scenarios, the assets, the liabilities, different parts of the business adding up through the group reinsurance vehicle. We aggregate that up, we rank it, we look at it by risk, we look at it at total capital level, we allocate down to risks, and we produce a number of different outputs for the different businesses at the group level, different percentiles. So there's quite a bit of functionality that over a period we'd built. So we needed to build this into IM3, luckily I had someone in my team who's much better at coding than me. In fact, a couple of guys in the team who then took this on. And the guy eventually built most of it, Hugo, I'll give him a name check, Hugo Tam, did an absolutely fantastic job. And probably in about 3 weeks, maybe 4 weeks, he'd got broadly the whole calculation working. Now, it wasn't the full-end final version with all the different outputs and all the different inputs with flexibility, but broadly it could do the calculation end-to-end and reproduce year-end 14 numbers. And you can see some of the remarkable runtimes that we got from the system. And this was not after months of tuning, this was first time through. So instead of Algo taking 2 hours 30, if I take a sort of a slice through these different steps, we could get it running in about 2 minutes. And this was on one desktop computer instead of Algo, which was running 500 computers on a remote data center. Now, it wasn't using all of those at one go, but it was using a chunk of them. So at any one time, you might be using something like 30 very high-spec computers instead of one desktop. So sometimes I talk about one of the core bits of the calculation is 30 times faster on 30 times more compute. So I basically round that up as 30 times 30 is 1,000 times faster, sort of core for core, if you like. So you might hear that. I think it's somewhere on the Julia website. That's where that number comes from. So very easy to pick up, very easy to regenerate. Numbers that we had an Excel spreadsheet, so we knew the calculations that could, and we needed to turn that into a working Julia bit of code. So were there any problems? Well, probably 3 challenges along the way that nearly tripped us up. Well, didn't really. We knew we could solve them. It just took us a bit more time. The first was we sample a lot of distributions. I'll just take you back there to the previous slide. That risk factor scenarios bit, the bit that takes 1 hour and 30 on Algo. There are 1 or 2, if you're sampling a log normal or T-distribute, they're very quick. There are simple ways of getting a particular percentile from a CDF. But there are 1 or 2 tricky distributions, and we have one in our data set, hyperbolic distribution, that we use many times. It's well known for it's a sort of fat-tailed distribution that you can apply skews to and things like that. It's commonly used, I think, for equity fat tails of rare events. And anyway, that's one of the data points that we've got. And sampling that is a very complex calculation. There aren't any closed form solutions. You've got to do it by numerical integration. And if you try putting that into R, it takes forever. There are some tricks to speed it up. What we eventually did was we just went through one very, very fine-grained pass. The PDFs were pretty quick. We went through the whole thing, adding it up so that obviously if you add up a PDF, it should add up to a CDF to be 1. And we could get that, and we could check that the error was small enough, and if the error was big in any particular step, you could just halve the gap and smooth that out. And as you go through that, adding it up, you know where you are in your cumulative distribution, just to output every 10,000th quantile. So it's a single pass through your distribution, output all your quantiles, and then you can interpolate those. It's a very fast way of generating a lot of points on a very complex PDF. So that's how we solved that one. And actually, we could, because we knew it was the right answer, because it added up to 1, we could check it against R, and we found actually some bugs in the core R distribution for hyperbolic. The next one was the nearest correlation matrix problem. So we have correlations between our different risk drivers. When we set those up, there's a process where each business sets them up, and then we fill in the gaps, and it's a big correlation matrix, 200 by 200. You can't possibly set every single point and make it Cholesky decomposable for a a correlation matrix requirement to generate correlated normal 0 1s, which is our basic requirement. So we need to create an equivalent correlation matrix to something as near as possible. So there's quite a lot of academic literature around this. We had in Algo something called the Rebenato-Jackal method from 1999. So we had a look at it. We found a better method, the Higham APM method, with a bit of a speed up on it. We implemented that, and we've got a much better technique than we had previously in Algo. So again, that's a great one. At some point, these should be put into some standard package, these techniques. I know distributions package, whatever it is doesn't have the hyperbolic, so you should put it in. But it is quite a tricky one to get to run at speed. Right, there you go, Simon. It's used more widely than in Aviva, I believe. And nearest correlation, you can go to the NAG library, MATLAB. They've all got these sort of NCM type algorithms, so it's again something you might want to look at. Reproducibility, one that's still tripping us up, just came up the other day, that we've got different instances. We have desktop where we do development, we've got cloud, small servers, large servers, and we really want, with the same random seeds, we should get the same numbers, and we do occasionally at the very, very extremes of our calculations do get very minor issues, and unfortunately, because of the way that the random normal ones are created, any tiny error, and these are out of the 10th, 12th significant figure, they can ripple through and change the order of the simulations, which will create a small simulation error. So we are still seeing one or two of those, so we've got to nail those. But those are some of the things that we found quite tricky. But I think you'd find, I'm sure in any application you'd find some things tricky if you're trying to reproduce a proprietary system. So that was our project. We went live, and this is how we're tracking. So this is an example of month by month. We have some various service targets. Our users we check that we're meeting our service targets. So how available has the system been? That's obviously a factor of how robust some of the framework around Julia is. It's not just Julia. So we've got a fairly big framework around it. And we're on Amazon Cloud, so it depends on that as well. And occasionally there are little glitches, servers go down. We have a run performance target for the business units for group. So we want to complete in about 20 minutes. That's our target for business units, and we easily beat that. We've got green all the way through. Our group runs 45 minutes is our target. So these are longer than the benchmarks I showed you a minute ago. Benchmark of about 2 minutes was a business unit, and we broadly keep to that. That was in the early version. Now we've built it out, and we're running a lot more reports, 500,000, not 100,000. So the runtime sort of go up fairly linearly with those sorts of factors. So we're running at more like this sort of 20 and 45 minutes is top end of where we want to be. We want to be within that target. And you can see the group runs, had a few problems with the group run, so we put a few more big servers in, and that speeded that up. So there's less queuing. As more requests came in, occasionally they'd queue, and that was the reason, rather than slow run times. And we want to reduce the number of failures, so that's about trapping inconsistent user inputs, that sort of thing. So those are some of the benchmarks. So we really treat it as a true production system. It's live 24/7, any day of the week the users can use it in all those different businesses around the world. There's an example or an indication of the number of runs going through a month. It's not a huge number. I mean, 1,400 there's our record in January. I guess it depends what you think a large number of runs is. People don't really do these for fun. It's part of their job. They have to produce numbers. I guess if they were playing around, they might do more runs, but they have other things to do in their day. This is sort of proper production work. So they'll do base runs, they'll do sensitivities, they'll do roll forwards each month, and then there's quarterly processes, plan processes, and this spike is at year end. So year end is a big process for us, and you can see a breakdown there of some of the businesses, and see the big purple bar there. That's the UK Life business, which is our largest business. Okay, so that's a bit about how it's running in production. Lots of users all around the world running it. Where do we go next? Well, we've built our first application. Finn, who's in the audience actually, there you go, put his hand up. He's helping us to rewrite the credit risk system, which coincidentally is also another algo system. It could have been another system. We're actually looking at a third system as well, which isn't algo. So we intend to transfer that. We're very pleased with Julia, and there's no reason why we can't repeat the same trick. We're pretty confident we can reproduce the calculations in Excel. If I can do that, then I can definitely put it in Julia. So there's no reason why we can't do it. What we'd like to do, and I'm interested to know a bit more about Julia Run in a few minutes, we're actually looking to put it on Spark and distribute through Spark as a sort of a cluster management capability, probably because we may use other solutions. We might write some C code, and we might sort of mix and match a bit. So this gives us a bit of flexibility, although at the moment our main use cases are Julia. And Avic and others, Simon here, we're hoping, Avic's definitely helping us with the Julia binding for Spark. and Simon, I'm hoping, can come on board and help us sort of with some advice about how best to build in this sort of distributed Spark world. So this is going to be a heavier use case, I guess, that we've got to get into production. Meanwhile, we want to look at optimizing the IM3 solution, the first one that we were talking about. So that's where we've been, that's where we're going. We're now, I've got a couple of people in the team who are very skilled in Julia. We're now branching that out and building more skills in the team. So that's our story so far.